Now, one of the situations we have to appreciate is our machines are always in a risk state, always in a state of risk, because every single part in a machine, and this is just a pump set, this is a simple one to talk about, but every single part in the motor, every single part in the wet end are all degrading at their own rate, depending upon how that machine is being used, depending upon how flat that base plate is, depending upon how aligned those shafts are. So every component in there is degrading. Each component has its own P point and its own F functional failure point. And when any of these hit a functional failure point, that machine stops. So this degradation curve applies to the machine as a complete assembly and also to each individual part. And because each part has its own curve, it means each part has its own effect on that component. And this is a random situation. When the P point on the impeller appears, and when the P point on the bearing appears, and when the P point on the winding appears, it's up. Don't know. It's all whatever happens. It's a risk situation. So we've got a risk situation where if we are unlucky and it fails and there's we don't pick up the problem until it's a major cost, then that cost can be excessive. If I pick it up early before the functional failure, I can do a planned job, and that planned job is a certain cost. If I miss that and we go to a breakdown, then that cost is unknown until we actually can fix it. So we have an unknown cost scenario depending upon which part fails, when it fails, and the circumstances around that situation. This degradation curve, of course, depends upon the stress in those parts. This degradation curve can be very long if there's low stress and not often the machine's not used very often. Or if there's high stress and high temperature and high loads, high pressures, that curve can drop away very quickly. So I've got a situation of unknown cost and unknown time when things are going to happen. So the whole situation is a risk-based scenario. There is so much uncertainty that we are trying to understand and control, which then means I have probability. Probability becomes a factor in understanding my options that I've got available to do. So yeah, our machines are a bit more difficult to work with than simply looking at those and using them and maintaining them. There's a lot of unknowns, a lot of risks always present, and depending upon how those holes in the Swiss cheeses that we use as barriers, as maintenance, operating practices, installation practices, selection practices line up, these failures could happen at any time and could be any cost. So if I've got a risk situation, it means I can then use a risk matrix to model that situation. I want to turn the unknown into something visible. That's the whole point of having a risk matrix. To talk to people about, look, this is where we are right now. Here are the many impacting factors. If we are very unlucky and we miss the P point and we end up in a breakdown, that breakdown cost will be here. Now that's worst case. So it's very easy to find the worst case scenario, worst case cost, and that's the only thing you and I will ever agree on. What's the worst case situation if that pump fails in this business, and we can calculate that worst case scenario. So I want to know the worst case first, because that one we'll both agree on. There'll be no fights over that. What we will argue over is other situations and other costs that could arise. But if I can find on my risk matrix the unquestionable worst case scenario, then we've got a point to start with. I'm then going to ask, in this case here, our pump has got a problem. The curve is beginning to drop away. So we've raised a work order to repair this pump. Vibration or temperature or something's triggered off a recognition of the degradation happening. In this case here, I've given myself a week. Our understanding is between the P and the F, the PF interval, PF window, is about a month from our experience of machinery and of the science of failure. So I said, okay, let's raise a work order and repair this in the coming week. If I can get to this machine in the coming week and do this job, then I know the cost. It'll be a planned cost. It'll be maybe 2 hours outage, maybe 3 hours outage, which I can cost up the lost production time. So I can get a number that reflects a planned job outage and show that on my risk matrix. If I can get to this job as we plan right now, the cost will be here. And it may in fact be in the blue depending upon the total cost. But the point is I can get now 2 ends of an envelope of risk. Now if I then say, look, I'm sorry, can't give it to you this week, I'll give it to you next week. Well, now 2 weeks into our 1 month. Now, I'm counting on that curve not changing. I'm counting on that curve to be 1 month degradation. But it might change. I have no idea. It depends upon the stress in that part. That curve can drop away like this. So I could be very unlucky and we agree, okay, let's reschedule 1 more week. And I'm hoping, I'm praying that it doesn't fall away in that 1 week period. If it does fall away, bang, breakdown, I've lost it all. If it doesn't fall away, then my risk has obviously moved up because I'm now halfway into a 1 month and I'm not certain I'll actually make that full distance. There's a degree of uncertainty. The risk is always there and getting more and more the longer and longer I wait. Because I know after a month I will definitely be in a failure situation. I'm 2 weeks into a month, that risk must be rising. The longer I wait, I must be rising in risk. So now I've got a picture of what's happening now, Mr. Production Manager, with that pump on your process. When it fails, you will lose $200,000 in an instant. If we get to it next week, it only costs you $20,000. If we go another week later, we could be putting the company in jeopardy. So now we've got a real visual indicator of what we're carrying. Now, it's not hidden anymore. Could be as bad as $200,000, could be as cheap as $20,000. You make the call, Mr. Manager. You're the plant owner, you're the operators of the plant, you own that equipment, you decide. Now, when we have a car, we decide when to put the car in for a service. We decide which service station and which service people do that repair. Same with operating plant people. They own the equipment and they have the right to decide how they wish to use that plant. What they often don't see is the risks they're secretly carrying but don't realise they're carrying. So I want to make a visual indicator of, hey, this is the risk envelope and anything in there could happen. Now this risk envelope is obviously in a high extreme risk area. So if this was a true situation, anything we do here, we have to be very careful of because the amount of money we're going to lose here is high money. If that envelope spread across into my low risk area and I'm still sitting down here after a fortnight, I might just say, look, we're going to push the barrier here. It appears as if I'm going to have a bit of room to play with. Now, if the uncertainty is too great, what we then do with our technician, if the uncertainty is, hey, I have to be more sure that we're going to make the whole month, then what I'll do is get a vibration analysis guy down or an expert in pumps and say, come down, tell me please what you think is happening with this pump. Will it go the 2 weeks that we want? So this uncertainty, we don't have to necessarily live with. There are ways to be sure if this curve's falling away fast or degrading slowly, but it may require a professional expert in that area of knowledge to advise us in that.